Hello, afternoon. Well, it's afternoon here anyway. Okay, so I want to talk about using Asymptote like MetaPost. And the abstract is that Asymptote is a descriptor vector graphics language for technical drawing that fits well with LaTeX and friends, and I think it deserves to be more widely known. So that's why I'm talking about it. One appealing thing is that it's in part based on the algorithms from MetaFont and MetaPost, but it extends those to three dimensions. I'm going to discuss a couple of workflow things that a beginner to the system, particularly a beginner who's coming from MetaPost, might like. And the main one is using a single source file to output many related graphics. Okay, so the introduction, again, I don't think that Asymptote is as widely known as it deserves to be. Asymptote is a powerful descriptive vector graphics language. It uses a natural coordinate-based framework for technical drawings, and LaTeX, of course, TeX, typesets the text and the equations. To me, one of the appealing things is that it is a good impedance match for what goes on between my ears. When I think about a graphic, I think something like, let's say it's a 3D graphic. I think something like, okay, so draw the axes, and I want to do an orthographic projection. I'm going to be at 10, 5, 2, and looking at the origin, and I want to put a sphere over here and a box there with a red line between them. That all those things are easily said in this system. Of course, there are other systems that also have this capability, but I'm talking about this one at the moment. So basically, what I just tried to say is that it's mathematically oriented. It's not kind of a drag and drop system. It's inspired by MetaPost, but it has a more standard C++ like programming syntax. I don't know. I always found MetaPost very hard to program in. It's IEEE floating points, and it fully generalizes MetaPost's path construction algorithm to three dimensions. So it's time for a picture. So let's see if I can work this thing. There we go. Okay, so I'm at the Asymptote web page. So asymptote.sourceforge.io/gallery/3D graphs with a D is capitalized. And I just picked a graphic because I thought it was a reasonable graphic to use for this purpose. Where'd we go? There we go. Okay. And you can see that it does a nice job drawing pictures. I mean, the figure does the kinds of things that I want figures to do. It does a good job drawing the planes in the back, the left side and the bottom. It draws the sphere part very well. You get the letters drawn in LaTeX and the different colors and the arrows, and I don't know, it all looks the way that I want my graphics to look. So that's appealing. A person probably is saying to themselves, well, what does the source code look like? So fair enough. So here's the source code, and to me, without going into it at great length, I'm not going to go into it at great length, it looks like the kind of programming language that I'm using when I'm not using this. That is to say that it looks like a standard programming language. The lines end in semicolons, you declare things, all the things seem pretty routine. So it is something that if I put it down for 2 months and pick it up again because I have some bug and I need to fix the bug, I'm not saying to myself, oh, how do you do that again? It all has the sense of the kinds of things that a person usually does. And just very, very very briefly here, you import the three-dimensional code, you import the math code, you put into the preamble of the TeX document that is used to draw to make, for example, the lettering on the diagram you just saw, use package BM kind of thing. There's some parameters, and the current projection is perspective from location 4, 1, 2, looking toward the origin. Then you draw the surfaces, the back, the left, back, and bottom, and etc. You start drawing the figure, and it all does what you'd think it would do. So I find that appealing because, like I said, one of the things that characterizes working in this language is that I don't work with it for months at a time. So the fact that it does what I expect it to do is a big plus for me. Okay, so let's see. Back to the discussion that I was having. The second point is that it generates high quality output, high quality PostScript, OpenGL, PDF, SVG, WebGL, V3D, and PRC vector graphics. So alphabet soup. Even if you don't know what a lot of those letters mean, I just want to discuss the PRC vector graphics. So if you're making a PostScript a PDF output file, and you want one of these things where you reach out with your mouse, you're drawing a 3D graphic, you reach out with your mouse and you click on it, and you can turn it and look on different sides, pick it up, look underneath, kind of stuff. That's PRC. Okay. And as well, it does a 3D vector WebGL graphics. I want to show that too. So let's see if I can manage to work the system to do that. Here we go. Again, this is from the Asymptote webpage, and I just kind of picked a graphic here. This one here, it's called Gaussian Surface ASY, and it's, that's WebGL. I mean, that's all happening in the web page. How hard is it to draw? Well, it's not hard at all. It does what you think it would do. You import the 3D graphic drawing. You make the figure be 200 by 200. That's PostScript points. But anyway, your current projection is a perspective from 1048. There is, you recognize the relevant function, and you draw the rectangle underneath it, and it's all pretty straightforward. I mean, of course, the things have to be learned, but it is at least not some kind of crazy stuff. So that's appealing for me, because probably most people watching this video know that I'm not the brightest bulb in the box. So it's helpful to me to be able to work with things that are familiar. One of the things that I like about it is that it recognizes a problem that I've had many times. I'm sure everybody watching this video has had. You have some figure and you need to adjust it. You might say want to scale it up to be 1.1 as big as it is now. And when you do that, you go, okay, now it's the right size. It fits where it's supposed to go. But wait, I scaled up the letters too, and I didn't want to do that. So it has some sense that some things are scalable and some things are not scalable. And I think that's a big plus for me. That makes a lot of the jobs that I do a lot easier. And then finally, just something fancy, you can run it in your browser without installing it, the Asymptote web application. So I think that's zippy, so I want to show that. Come on, there we go. And there we go. And you of course type in the Asymptote over here, and the outcome, output appears over there, and it's nice. So you don't have to, if you want to just try it for 20 minutes, you don't have to install it on your computer. Okay. Okay. So I'm imagining that most of the folks, maybe every person watching this video, is saying to themselves, why don't you just use TikZ? And so I want to address that rather than wait till somebody actually asks the question. So TikZ is very widely used. Asymptote is a much smaller user base. I personally have not used TikZ very much, and I haven't used it lately at all. But when I started my latest project, which is a discouragingly long time ago, anyway, when I started my latest project, I wanted to look around and see what to use for the graphics, and I compared the different things that were available at the time. I found that Asymptote had some relevant technical advantages, including native 3D graphics, and I also found TikZ harder to programming in. Now that may have changed, and people could say, well, but you don't realize that. Maybe. Obviously, your mileage may vary. Another difference between the two, relevant for this conversation, is that the basic paradigm in TikZ is that your figures are in your document, generated when the document is generated. In Asymptote, the basic paradigm is that they're generated outside your document. Now, I understand you can absolutely generate standalone graphics in TikZ, and absolutely you can include Asymptote code in a document, but the basic paradigm is what I said. And we all have experience. Sometimes if you go against the basic paradigm, it isn't that everything breaks, but it's just that things get to be a little harder, it gets to be a lonelier place. So I like it when you have some idea what the system kind of is tuned for. One of the things that for me, I didn't want to use TikZ was that in the past I had a bad experience with a book from a long time ago using PS tricks. And then the LaTeX world switched to PDF LaTeX. So it was a long time ago. But it made an impression on me. It left me with a strong preference for a dependence chain that is shorter and broader over one that's taller and thinner. If you have a lot of prerequisites for your document, all these things need to work for your document to come out. I don't know, that makes me nervous, in part because of that past experience. So I wanted to generate the figures independently from the document. Again, your mileage may vary, and if I was generating a 5-page document for calculus class lecture, that's all fine. But anyway, that was my part of my reasoning. Okay, finally, time to get to the main point. So in MetaPost, I wrote a book many years ago where most of the graphics are in MetaPost for a person who cannot draw, being able to, for instance, tell the computer that you want to put this equidistant from those 2 points instead of dragging it and going, that looks halfway, is a big help. The basic structure in MetaPost is that one file holds many figures. It will output a graphic into a file numbered 1 and another graphic into a file numbered 2, the gray material there. So begin fig 1, begin fig 2, figure drawing commands go in the middle. If you're drawing, for example, figures for your calculus lecture, then you might put at the top of the file something like declare vector thickness equals 0.8 points and use that in lots of the figures. So putting all the sources in the same file is convenient because you could change that parameter and make it do what you need, if you want to make some small change. But having worked with MetaPost, I was aware of some warts. So when I started my latest project, I wasn't sure I wanted to use it. For me, the 2 biggest warts are the lack of any real 3D ability, and that programming in MetaPost can be quirky. I'm sorry, suffix variables? I don't know. Anyway, so when I saw the new Asymptote system, I saw a presentation by John Bowman, one of the Asymptote authors, at the San Francisco tech meeting, and I was just blown away. I was eager to try it, and it has been very good. I'll describe the 2 adjustments that may help a person coming from MetaPost that took me some time to dope out and to fine-tune to make them work the best way I could get them to work. The first one, the main one, adjustment 1, multiple figures per file. The basic paradigm in Asymptote is to have 1 figure per input file, and so here's a skeleton of how to put multiple figures in a file. This will output the file test000.pdf containing a graphic with a diagonal red line, and so just to go through the code, I declare string output underscore fn to be test %03d, and then, there's the semicolon that ends the line. So in case the letters are a little small for folks to see. Down here, I declare a picture, pic. I declare pic num to be 0, an integer. And the unit size for pic is 1 centimeter. That means that if you make a tick at 1, then it's a centimeter from the tick at 0. And then I draw in that picture a line that goes from 0, 0 to 1, 1, and I'm going to draw it in red. Okay. And then finally, I'll ship out that figure. I'm going to take a pic num, which is 0, and put it into the output fn using the format command, and then I'm going to put out the figure. That'll be the name of the figure. Put out the figure, and I'm going to put it in the format PDF. Okay, so I imagine that everybody can guess a lot of what's going on here, at least a lot of what's going on here, maybe everything that's going on here, but I want to make a couple points. The first is that output fn gives all the file names the same structure. So if you have lots of graphics, and my current book has more than 2,000 graphics, then it's easier to work with them. Of course, the string test $03d causes the picture number to be formatted as a 3 decimal place integer. I find that 2 decimal places in the file name is a little bit tight. You could run out. So 3 decimal places, I don't see myself running out. Okay, so that's the first tip. The second tip, I'm going to scoot back here for a second. I hope that's not annoying. I write pic num equals 0, and when I go to make the next picture, I write pic num equals 1, and when I go to make the next picture, I write pic num equals 2. I write pic num equals 0, pic num equals 1, etc., rather than pic num equals pic num plus 1, because it took me a while to figure this out. When you go back into a file that has 80 pictures, and you're trying to fix a bug in picture number 53, oh man, you really want it to say pic num equals 53. You don't want to be counting with your fingers, 1, 2, 3, 4. No, that's bad. And finally, the last point, Because I'm outputting multiple pictures from a single source file, I have to put in this pick command. I have to say where, for example, I'm drawing this particular line. I'm drawing it to the picture called PIC. So that picture will appear with a diagonal line that's in red, and if you leave out the PIC, then it will draw the diagonal line in red to some picture, but not to the picture that you output. That is to say, because it drew it somewhere, there's not an error message, but you go to look at the figure that you think you're drawing, and it doesn't have the diagonal red line in it, and I forgot the pick. So that's you got to put the pick in all of those commands. Okay, so again, the format there is not all that hard, but I basically copy that over and over again for all the pictures that I draw. I want to talk about a second adjustment that is related to the first. With the prior adjustment, the goal was if you have a lot of figures all in the same file, you have picture 1, picture 2, picture 3, picture 4, then you can, for example, have parameters at the top of the file, or maybe you define a function to do a certain thing, and it's convenient to have it all in one file. Even just sometimes you say, oh wait, I want to make this look like figure 53, except so you go up and copy figure 53 down. So it's uniformity that I'm after. You can have some parameters such as font size, for example, and describe them all just in the one file. But likewise for uniformity, you also want to have a consistency across a set of files. So in my book, for example, I have 5 chapters, and I have an Asymptote file for each of the 5 chapters. I have to have a number of Asymptote files for each of the 5 chapters, and I want them all to use the same colors for, let's say, the finite state machines. Okay, so I want to somehow have something like a single file style.asy that gets input into every Asymptote source file. Mine's actually called jh.asy because I named it that way in the first place and wasn't thinking straight, and now I'm pretty locked into it. So here, for example, is part of my style file for the most recent book, just as an example of the kind of stuff that you want in there. So I want, for example, to set the font size that's used to draw all the figures. It's a little bit smaller than regular font size. This is small, LaTeX small. That's why it has all those silly decimal places. And then I want to set the colors. I happen to set the colors using when I make the pictures, I use highlight color, background color, bold color, light color, very light color kind of stuff. And then I can change those without having to change the name of the colors by setting them. There's a certain amount of abstraction there. But so I'm setting the colors that are used in all the graphics in the whole book. So in principle, I could adjust those. I've never done it, but in principle, I could adjust those. Okay, so I have this one file that works across all of my Asymptote input files. So where to put it? So there's 2 cases, simple case and not so simple case. You can bring in a file with import file name, just exactly what you'd think it would do. If that file's in the list of directories searched by the Asymptote system, then you're good, you're home free. And again, this is going to work for 99% of the cases. So if you're a beginner, this is what you want to do. For instance, Asymptote has a standard file called settings that you often want to bring in. Here we go, import settings. And maybe you want the output format to be PDF. So this will make the output format be PDF for all of the graphics in that file. The place where Asymptote searches is just what you'd think it would be if you're an experienced person. It looks first in the current directory, then it looks in the environment variable asymptote_dir, and then it looks in the directory given by asymptote_home, etc. It's just what you think it would be. So again, if you're a beginner, if you're looking to set up the system, this is just exactly what you're looking to do. However, I have a more complicated case. I provide the files for my book in a Git repository because they're freely available, and I've had bad experience in trying to depend on people knowing how to get it working. So, for example, people seem not to be able to set an environment variable. At least the kind of people who are downloading my book often seem to struggle with things like setting an environment variable. Maybe they're just not reading the instructions. I don't know. When those folks are unable to get it to go, they sometimes write me, and that certainly means time, but it sometimes means a certain amount of aggravation. They sometimes write you an angry email that says, it doesn't work, So if there's a way to import files that doesn't require that, I'd be delighted. So I just wanted to comment that I have a way that does that. I'm more able to depend on people naming the download directory. That is to say, people who download the files always seem to use a limited number of names. Computing, because that's the name that I used for the book. It's on the theory of computing. At the GitLab, I keep it on GitLab. The GitLab project directory is TOC, so people who clone the material often clone it to TOC. And if they download the zip, then that's called TOC-master. So they often find you often find that the top level directory is TOC master. And this covers like 99% of the cases, maybe 100% of cases, I don't know, but it covers almost all the cases. And so I can depend, I think, on people having a directory of one of those three names. So you can see where this is going. I wrote a routine to look through the path of the current file for one of those three strings and then do the searching for my style file based on that. So it's not a very sophisticated file. It's kind of crude, but it will give a person some sense of one of the things I've been trying to say the whole time, which is that it is a regular programming language, at least regular enough for my purposes. So you get the current directory by issuing the command cd with an empty string. That's just how you do it. And then I do an rfind for computing or TOC or TOC master. And I figure one of those three cases has got it covered. Those turn out to be eight things I have to worry about. And then I write very ugly code to write those 8 things. But it's all the kind of code that I'm used to writing on a daily basis. So I find it relatively easy to work with. Okay, great. So that's all I had to say. Asymptote does a great job with drawing technical graphics. It deserves to be better known than it is. I urge people to give it a try. And to me, one of the things that's appealing about it was that adding some MetaPost-like workflow makes it work even better. Okay, very good, very good.